All right, so this is lesson 3, Toss the Cup, where it says we're determining experimental probability of simple events. So, learning goals, predicting the experimental probability of a chance event by collecting data in a probability experiment. Develop a probability model using frequencies and data generated from a probability experiment. Use proportional reasoning to determine the theoretical probability of random events. Calculate the difference between theoretical prediction and the experimental results as a percent error ratio. Key terms include theoretical probability, experimental probability, and percent error. You can create probability models of simple events. Do these models always reflect what actually happens when you toss a coin, roll a number cube, or spin a spinner? How are the probability models related to these actions in the real world? Write each fraction as a percent. 3/10 would be the same as this, which would be the same as 30%. 1/4 is 25%. Times it by 5 to get 45 over 100, or 45%. 2/5 times both by 20 to get 40 over 100, or 40%. All right, getting started. Flip it. With a partner, flip a coin 30 times, record the results, and then calculate the probability of each event. All right, so tails. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. All right. So, flipped a coin 30 times, and I got 12 heads, and I got 5, 10, 15, 16, 17, 18 tails. Heads, the probability would be 12 out of 30. For tails, it'd be 18 out of 30. Okay. Combine the results of your experiment with those of your classmates, then calculate the probability of each event. What is the actual probability of flipping heads? 1 out of 2, or 0.5, or 50%. In fact, if I go back to the probability there, we would have 12 divided by 30 was 0.4, or 40%. Therefore, 18 out of 30 should be 0.6, or 60%. Okay. How does the actual probability compare to the calculated probability in question 2? So this was heads. And so for heads, we're at 40%. So the actual of 40% was less than the theoretical of 50%. Okay. And what they would have liked to have had us do is, if the whole class does this, then that would have been a whole bunch more trials. And the more trials, typically the closer you get to the theoretical probability. Okay? So the experimental probability is going to be different, but the more you do the experiment, the closer it usually gets to the theoretical probability. And that's what they're going to try to show us by doing it with the whole class. All right, so activity 3.1, determining experimental probability. Two friends are designing a game called Toss the Cup. The game is played between two players. To play the game, a paper or plastic cup is needed. To start the game, the paper cup is tossed in the air. If the cup lands on its bottom, player 1 wins a point, like right here. If the cup lands on its top, player 2 wins a point, like right there. If the cup lands on its side, neither player receives a point, like right there. Okay? Predict the probability for each position in which the cup can land. That's going to kind of depend. I think like the side would be like maybe even more. And then maybe this would be 25%, and then maybe this would be 25%. So those are my predictions right there. Okay. List the sample space for the game. Boop, boop, boop. It can either land on its bottom, it can land on its top, or it can land on its side. Can you use the sample space to determine the probability that the cup lands on its top, bottom, or side? Explain why or why not. No. I don't think these outcomes are equally likely. Do you think all the outcomes are equally likely? No. I think the cup will land on its side much more frequently. Okay. All right. So play the game 25 times with a partner. Decide who will be player 1 and who will be player 2. Does not matter. All right. Let's see what I can do here. Maybe I'm going to adjust this a little bit, and so it's going to be a little goofy, but that's okay. All right. So I'm taking the cup here that I have, and I'm going to flip it, and I'm going to flip it apparently 25 times. Side. 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 Huh. 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 Which one was that again? And it's like that. It's on its top. So that's top. Okay. Side. Redo. Side. 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 Oh. Top. Side. Oh. Side. Top. Top. Nope. Redo. Woo! Bottom. Woo! Bottom. Side. Side. Let's see here. 13, 14, 15, 16, 17, 18, 19, 6 more. Woo! Bottom. Nope. Redo. Side. Side. 15, 18, 19, 20, 21, 2. 3. Oh, redo. Woo! Nope. Side. All right, so we got 17 there. We've got 5 there. We got 3 there. Okay. So record your results in the table using tally marks, then write your and your opponent's total score. Well, the score, yeah, that'd be the score because it's 1 point per. All right. And write the number of times the cup landed on its side. Done. All right. Summarize your results. I don't know. Player 2 won. There were a lot of sides. Okay. Let me adjust this again. The theoretical probability of an event is the ratio of the number of desired outcomes to the total number of possible outcomes. This is the kind of probability you've been working on in previous lessons. What we've been doing here today is experimental probability, and it's the ratio of the number of times an event occurs to the total number of trials performed. So experimental probability is the number of times the event occurs over the total number of trials performed. So on its bottom was 3 out of 25, which is 0.12 or 12%. On its top was 5 out of 25, or 0.20 or 20%. And then on its side was 17 out of 25. So I'm looking at the experiment to get my experimental probabilities. Times that by 4. 2, 68, I believe. 0.68 or 68%. Okay. Do you think this is a fair game to play? Why or why not? Too soon to tell. I mean, it landing on the top happened more than it landed on the bottom, but we only did it 25 times, and so maybe it'll even out. And I definitely was getting a little better at tossing it after a bit, and I wasn't really trying to get it to land this way or land this way at first. All right? But let me read the next one. Is it possible to determine the exact probability of the cup landing on its top, bottom, or side? Explain your reasoning. Is it possible to determine the exact probability? No. I think it depends on the cup. Some of you geniuses out there, you probably said, hey, look, it's got to be easier to land this way because this is a bigger circle. It's got a bigger landing area. And this way is a smaller landing area. And then you take this cup, and I don't know what the difference is, but this is still smaller than the top is. But I think it might be a little closer. And so maybe it'll be easier to do it that way or that way. Or I think it'll depend on the cup. And so the exact probability will depend on what you are flipping. Okay, so we're doing some experimental probability today. We were prior to this doing theoretical probability. I like to think of it as theoretical, you don't do the experiment, and experimental, you do the experiment. I said do. And so this is our intro and our first part of lesson 3.